A database is more than just a collection of tables. It's a web of relationships. If you have ever struggled with broken data, confusing drawings, or unexpected deletes, the root cause might be right there. Let's define what related tables are and how foreign keys hold the web of tables together. In this video, you'll learn the basics of related tables and how such tables and their data are managed. Let's get started by defining related tables first. So what makes two or more tables related to each other? Let's use an example to explain this concept. Think about an online store named the Sci-Fi Collective that sells sci-fi products online. There are two tables in its database. One represents the products that are sold, while the other represents the reviews associated with the products. Since each review is for a specific product, the review table needs the help from the product ID column to remember which review is for which product. As a result, the two tables share a common column, the product ID. If you need to see what the two tables look like with some data in them, here you go. As you can see, the value in the product ID column helps connect a row in the product table and a row in the review table. For example, in the product table, there's a row with a product ID value as 3. It records a product named cat poop coffee. In the review table, the row with a review ID value of 1 records a positive review for this product. How would you know the review is for the cat poop coffee? The two rows here have the same product ID value. That's why. So the product ID column is shared across the two tables. Its goal is to help the review table remember which review is for which product. And that makes the two tables related to each other. In the product table, the product ID column is the primary key. In the review table, the product ID column is known as the foreign key, which refers to the primary key of another table. In this case, the other table is the product table. Now let's define the related tables formally. The related tables are the tables that are connected by one or more common columns in a database. As curious as you are, you may wonder whether product and review tables can share a few more columns beyond the product ID. That's a great question about database design. You can even generalize this question a bit to all related tables, like this. Should the two related tables share columns beyond the primary/foreign key? The answer is no. To simplify our discussion, let's look at the scenario in which two related tables use single columns as the primary keys, the product and the review table. Theoretically speaking, the numbers of columns shared by the two related tables can range from only the primary/foreign key to all columns from both tables. Using the product and review tables as an example, the figure that you see here on the screen summarizes the spectrum. So it ranges from just one column on the very left side to all the columns on the very right side. If two related tables share every column, the same as what you can see here on the right side of the spectrum, it's obvious that one of them is redundant and that's unnecessary. If you choose to delete one of those two tables, you will still find trouble in the remaining one. This is the scenario where you use one table to represent two entities, and that will lead to insertion or delete anomalies and tons of redundancies. Even with just a few rows, as you can see here on the screen, you can still spot the redundancies. Okay, making two tables share every column is apparently a bad idea. How about making the two tables share only a few columns, such as one or two more columns beyond the primary/foreign key? That's also a bad idea. First, you would still have redundancies, even if it's less serious than a redundant table. Second, you will set a trap for yourself when you need to update data in such tables. If you update data in only one of the two related tables, but forget the other, you will end up with inconsistent data. Suppose that you decided to make the product and the review tables share one more column beyond the product ID column, the manufacturer column. When you need to update the manufacturer of a product, you need to update both of the product and the review tables. Otherwise, you will end up with new manufacturer data in one table, but outdated data in the other. Such a problem is known as an update anomaly. That said, given two related tables, they should share the primary/foreign key. If the primary/foreign key is a single column, then the two tables should share that column. If the primary/foreign key is composed of one more columns, then the two tables should share those columns. However, they shouldn't share any other columns beyond the primary/foreign key. Now you know what the related tables are. Let's move to discuss how to manage related tables. We will start with the foreign key constraint. So to properly introduce the foreign key constraint, we will use an example and start with a question. How do you create two related tables? For example, how do you create the product and the review tables for the database of the Sci-Fi Collective? Well, you can actually create the product table in the same way as if you are going to create a single table that's independent, that's not related to any other tables. Okay? You can rely on the help of the create table command, then that's going to be followed by the table name, then a bracket. In the bracket, it will wrap up all the columns line by line, separated by commas. In each line, you will list the column name and the data types. You are also required to specify which column will be used as the primary key. But what about the review table? The review table can be created with the help of this command, as you can see here on the screen. This is still a create table command, of course. However, there might be some clauses that you see for the first time. To explain this clearly, we need to discuss the general syntax of creating related tables first. So what's the general syntax for creating two related tables, or say two tables that have a relationship? As you know, the shared column product ID is the primary key in the product table and the foreign key in the review table. Given a pair of two related tables, we call a table like the product the parent table because it uses the shared column as the primary key. We call the table like the review the child table because it holds a foreign key. As you can see from the command that creates the product table, the syntax for creating a parent table is the same as the syntax for creating a single table that's not related to any other tables. To create a child table, you need to specify the foreign key that references the primary key in the parent table. You still need to define all the columns, data types, and the primary key, of course. The general syntax for creating a child table is presented here on the screen. Alternatively, you can create the two tables independently and add the foreign key constraint to the child table afterward, like what you see here. In both options, you saw the constraint foreign key clause. What does it do exactly? In short, the clause creates a foreign key constraint, which serves as a link between the two related tables. The constraint is twofold. On one hand, the constraint ensures that the foreign key column in the child table references only valid primary key values in the parent table. On the other hand, the constraint ensures that updating or deleting of rows in the parent table doesn't violate the consistency between the two related tables. We refer to these two aspects as referential integrity. So this long clause with three keywords, constraint, foreign key, then references, enforces referential integrity between two related tables. Referential integrity is an important aspect of data integrity. This clause is composed of two parts. The foreign key references statement creates a foreign key constraint that enforces the referential integrity. What about the constraint part? The constraint clause allows you to name this constraint. When you create a foreign key constraint, you don't necessarily need to name it, but naming it will make it easier to access whenever you need to modify such a constraint in the future. For example, in this example that you see here on the screen, we name the foreign key constraint in the review table as fk, short for foreign key, then product, then review, concatenated by underscore. As you can see, foreign key, then product table, then review table. That's how the name is made. If you ever need to drop this constraint, you can access the constraint via this name, like what you see here on the screen. If you don't name a constraint yourself, the database system that you use will name it automatically for you. The database system will use a default naming convention. Although the automatically picked name can be retrieved, the name and the default naming convention vary from one system to the other. To avoid this hassle, we would recommend you always name the constraints. After all, dropping or disabling a constraint can be a common task whenever you need to modify your database design. Now you know how to create related tables and declare foreign key constraint. A natural question to ask next is whether the foreign key constraint have an impact on adding data into tables. Well, the short answer is yes. We mentioned this briefly when we talked about the referential integrity, but here we want to show it to you very explicitly using examples. First, adding data into the parent table is not impacted. It's the same as if you were to add data to a table that stands alone. For example, this command adds another row to the product table. As the product table is a parent table, there's no impact from the foreign key constraint at all. Second, adding data into child tables is impacted by the foreign key constraint. It's manifested in that every row added into the child table needs to have a product ID value that corresponds to an existing product ID value in the parent table. For example, if you ever try to add a row into the review table, but this row's product ID value doesn't correspond to anything in the product table, like this, where 3000 doesn't exist as a product ID in the product table, you will receive complaints from SQL. If you think about it, such rows of data shouldn't exist in the database in the first place. If you are ever allowed to add such data into the review table, it only introduces troubles in the future, such as inconsistency and the trouble to figure out what non-existing products are referred to. That's how foreign key constraints protect the data integrity in your database. Deleting data from parent tables is also impacted. For example, if you try to delete the third row from the product table, the row whose product ID value is 3, then you are going to rely on the help from this query. Delete from product where product ID is equal to 3. When you try to execute this query, you will get complaints from SQL because this product has been linked to multiple reviews in the review table. If you are allowed to take this action, you will end up with some orphan rows in the review table that references some product ID values that can never be found in the product table, which will introduce a lot of troubles in the future. That's how foreign key constraints protect the data integrity of your database. For almost the same reason, you can't update the primary key value that's referenced in a child table. When you try, you will get errors from SQL. Beyond data management, foreign key constraint also has an impact when it comes to dropping related tables or updating table structure. Given two related tables, like product and review in the database for the online store Sci-Fi Collective, if you try to drop the parent table or change the parent table structure, such as renaming the primary key column or changing the primary key column from product ID to something else, you will certainly get complaints from SQL. If such changes can get through easily without any constraints, they may lead to many issues in the future and harm the data integrity of your database. If you really want to perform such tasks, you will need to drop the foreign key constraint first, and in the eyes of the database system, that is an explicit agreement that you understand the consequence of doing such a thing. So then you will be allowed to perform such tasks. In this video, you'll learn about related tables and how to manage related tables and their data. You also picked up some new concepts such as foreign key constraints and data integrity. If you are finding this video helpful, give it a thumb up, subscribe, and drop your questions in the comments. I would love to hear what's working for you and what needs to change. If you want to go deeper into database design, this video is based on the book Grokking Relational Database Design, which walks through these ideas step by step with real-world examples. You'll find the link to the book in the first comment.